For centuries, Betelgeuse has been one of the most recognizable stars in the night sky. Glowing with a deep reddish color on the shoulder of the constellation Orion, it has inspired astronomers, sailors, and storytellers for thousands of years. Unlike many bright stars that appear almost unchanged night after night, Betelgeuse has always behaved differently. Its brightness rises and falls over time, sometimes shining brilliantly before fading noticeably. Ancient skywatchers recorded these changes long before anyone understood why they happened. Today, astronomers know that Betelgeuse is a red supergiant, a massive star nearing the final stages of its life. Located approximately 550 to 650 light-years from Earth, every photon we see tonight actually left the star centuries ago. Looking at Betelgeuse is like opening a window into the past. The star we observe isn't necessarily the star as it exists today. That simple fact reminds us that astronomy is also a journey through time. Although Betelgeuse is cooler than our Sun, with a surface temperature of roughly 3,500 Kelvin, its enormous size makes it vastly more luminous. If it replaced the Sun at the center of our solar system, its outer atmosphere would extend beyond the orbit of Mars and possibly approach Jupiter, swallowing the inner planets entirely. Its immense scale makes it one of the largest stars ever observed with the naked eye. But enormous stars live fast and die young. Unlike the Sun, which can steadily fuse hydrogen for around 10 billion years, stars as massive as Betelgeuse burn through their nuclear fuel much more rapidly. Deep within its interior, fusion has already progressed beyond hydrogen. Over millions of years, the star has fused helium into carbon, carbon into heavier elements, and continued building increasingly massive atomic nuclei. Inside, Betelgeuse resembles a giant layered structure, with different fusion reactions occurring in separate shells surrounding the core. These nuclear reactions generate tremendous amounts of energy. That energy rises toward the surface through gigantic convection cells, vast currents of hot plasma that dwarf anything found inside the Sun. Some of these convective regions are so enormous that each one could span a significant portion of the star's visible surface. As hot material rises and cooler gas sinks, Betelgeuse's appearance constantly changes. Bright regions appear. Dark regions form. Its surface is in continuous motion. The star is also losing material into space at an extraordinary rate. Powerful stellar winds continuously push gas and dust away from the star, forming enormous shells that expand into the surrounding interstellar medium. Those outflows contain elements such as carbon, oxygen, nitrogen, and silicon, atoms forged deep inside the star through nuclear fusion. Eventually, this material will mix with giant clouds of gas that may someday collapse to form entirely new stars and planets. In a very real sense, many of the elements found on Earth were created inside ancient stars like Betelgeuse billions of years before our solar system formed. One of the most dramatic moments in Betelgeuse's recent history occurred between late 2019 and early 2020. Astronomers around the world watched as the famous red star suddenly faded to roughly one-third of its normal brightness. The event quickly became known as the Great Dimming. Some scientists briefly wondered whether the long-anticipated supernova had finally begun. Observatories across Earth and in space immediately turned their attention toward Orion. As more observations arrived, researchers reached a different conclusion. Instead of exploding, Betelgeuse had experienced a massive surface eruption. The star expelled an enormous cloud of hot gas that cooled as it expanded into space, forming dust that temporarily blocked part of the star's light from Earth's perspective. At the same time, part of its visible surface became cooler than usual, making the dimming appear even more dramatic. Rather than signaling the star's death, the event provided astronomers with one of the best opportunities ever to study how red supergiants lose mass during the final stages of their evolution. And despite everything we've learned, Betelgeuse continues to surprise scientists with new changes in brightness and behavior. Although Betelgeuse continues changing before our eyes, astronomers know that every red supergiant eventually reaches the same unavoidable destination. Its spectacular life will end in a supernova. Deep inside the star, nuclear fusion has been supporting its enormous weight for millions of years. Every stage of fusion creates heavier elements, releasing energy that pushes outward against the crushing force of gravity. But this process cannot continue forever. As the star ages, progressively heavier elements build up within its core. Eventually, an iron core will dominate the center of the star. Iron marks a turning point in stellar evolution. Unlike lighter elements, fusing iron requires energy instead of releasing it. Once the core becomes mostly iron, the star can no longer generate enough outward pressure to support its own mass. Gravity takes over. In only a matter of seconds, the core collapses inward at incredible speed. The collapse triggers one of the most powerful explosions in the universe, a core collapse supernova. During this event, enormous amounts of energy are released almost instantly. Powerful shock waves race through the star, blasting its outer layers into space at thousands of kilometers per second. For a brief period, Betelgeuse could outshine nearly every object in Earth's night sky. Some astronomers estimate it might even become visible during daylight for days or weeks, while appearing brighter than the full moon at night. It would be one of the greatest astronomical spectacles ever witnessed by humanity. Fortunately, there is no reason for concern. Even though Betelgeuse is relatively close by astronomical standards, it lies hundreds of light years away, far beyond the distance where a supernova would pose a serious threat to Earth. The explosion would be breathtaking to observe, but it would not endanger our planet. The greatest mystery is not whether Betelgeuse will explode. It is when. Current research suggests the star could remain stable for tens of thousands of years, and possibly around 100,000 years before reaching the end of its life. In astronomical terms, that is a relatively short period. Yet no one can predict the exact moment. It could happen long after human civilization has changed beyond recognition. Or it could occur much sooner than expected. There is even a fascinating possibility created by the immense distances of space. Because Betelgeuse is hundreds of light years away, we never see it in real time. Every image, every observation, and every ray of light reaching Earth today began its journey centuries ago. That means the star's present condition remains hidden from us. If Betelgeuse had exploded sometime within the last few centuries, the light from that event would still be traveling across interstellar space. We simply would not know it yet. Until that light arrives, the star will continue appearing as it did hundreds of years in the past. This remarkable fact transforms the night sky into a natural time machine. Every distant star represents history written in light. Some stars reveal events that occurred thousands, millions, or even billions of years ago. Betelgeuse reminds us that astronomy is not only about exploring space, it is also about exploring time itself. When its final explosion eventually becomes visible from Earth, the event will mark far more than the death of a single star. The expanding cloud of gas will carry newly created elements into the surrounding galaxy. Those elements will become part of future molecular clouds. Over millions of years, gravity may gather that material into entirely new stars, planets, and perhaps even worlds capable of supporting life. The oxygen we breathe, the calcium in our bones, and the iron in our blood were all forged inside ancient stars that lived and died long before our solar system formed. In the same way, Betelgeuse will one day contribute its own material to future generations of cosmic objects. Its ending will also become a beginning. The life cycle of the universe depends on this continuous process of creation, destruction, and renewal. Massive stars are not simply brilliant lights decorating the night sky. They are the cosmic factories that build the ingredients of planets, oceans, atmospheres, and life itself. Betelgeuse stands as one of the finest examples of that extraordinary cycle. Whether its supernova arrives tomorrow, thousands of years from now, or much later, one thing is certain. When that brilliant flash finally reaches Earth, humanity will witness the conclusion of a story that began millions of years ago, and the beginning of countless new stories still waiting to unfold among the stars.